For the Delta Math topic of coordinating a distance graphically, what we're doing on this one is we are using 2 points, okay? And we're thinking about, okay, what is the distance between them? And it would be lovely if we could just count, right? But we cannot just count diagonally. It's not the same. The diagonal of a square is not equal to the side lengths. So our trick around that is to use the Pythagorean theorem, which we learned this year. So in order to do that, you have to look carefully at your points, and you have to make a triangle, a right triangle out of that, so that you can count the edges, those sides, and just do the Pythagorean and the Pythagorean theorem, and that's the distance that you're going to be solving for. So if you create a triangle out of that shape, then you go back and you count the sides, the side lengths. Now remember, don't count the lines, you're counting the spaces. So there are 4 spaces along this side, 4 spaces along that side, and you can go ahead and like label that, okay? You can just do a quick sketch. You don't have to do anything fancy with a graph or anything like that. And then apply the Pythagorean theorem. A squared plus B squared equals C squared. Okay, your legs, the 2 perfect sides that are around that right angle, those are your legs, your A and your B. It doesn't matter which is which. You plug in those values, square them, and you get 32 equals C squared. Okay, now in order to know what C is, it's not just 32, it's C squared is 32. You do the inverse operation of squaring. You find the square root. These 2 things cancel out. Squaring and square root cancel out. The square root of C squared is just C, right? And so that's going to equal the square root of 32. And we're used to just plugging that in a calculator and calling it a day, right? But unfortunately, on Delta Math, they want to keep it in simplified radical form on this particular problem, okay? I think they even said that in the problem. Let me double check. Oh, the problem's way back here. Yeah, it says find the distance between the 2 points in simplest radical form. So when they ask for that, what they're doing is they're saying, all right, if you can divide out a perfect square and simplify just that nice, neat, little, tidy, perfect square, then do that as the factor. And 32 is the same thing as 16 times 2, right? So the square root of 32 is the same thing as the square root of 16 times the square root of 2, okay? These are the same thing. This one's just broken down. And we specifically picked 16 because that's a nice, neat, perfect square. And that simplifies to the number, the whole number, 4. Unfortunately, the square root of 2 is not a perfect square. So we're sort of stuck with it there. We can't get rid of it. It's part of that number. This is also the same thing as the square root of 32, but we just wrote it in what is actually a more precise format of an answer than if we had to round a decimal. So when they ask you to do things in radical form, it's actually a more precise answer. It just takes a little bit of getting used to. So it's not too bad, but that's how you do these problems. Okay, so with that said, you can go back and relabel your hypotenuse would be 4 times the square root of 2 and tell them each of the legs and the hypotenuse when you're giving the answer. Same thing on another problem, finding the distance graphically. You have the power to make that into a triangle. And when you do, those 2 distances are your legs. So you can easily count those distances by counting along the graph. Okay, those 2 distances in this case, in this problem, are 4 and 7. So we're going to now apply the Pythagorean theorem. Okay, a squared plus b squared equals c squared. So our legs for 4 and 7. Square those puppies, and you get 16 plus 49. Combine those to get 65. So let's do the inverse of squaring so we can get just plain old C. And we get C equals the square root of 65. And you ask yourself, are there any perfect squares that are factors of 65? Perfect squares are 1 and 4 and 9 and 16 and 25 and 36. And pretty soon we're too big, right? And none of those actually are a factor of 65. So that's as good as it gets. That as good as it gets. It won't simplify any further than that. So that's your final answer. And you'll go back and say, okay, one leg was 4, one leg was 7, and the hypotenuse in simplified radical form is the square root of 65.